Just 3 short years from now, in 2027, NASA is scheduled to undertake one of its most complex missions ever. Over a 12-month period, the agency is supposed to launch 2 separate probes to Mars with the goal of collecting samples from the surface and returning them to Earth by 2033. Once back, the plan is that they'll be analyzed for signs of ancient microbial life that may have independently evolved on Mars billions of years ago. But you probably noticed the key phrase in that last paragraph, supposed to. Because despite billions of dollars already sunk into the mission, the fate of Mars sample return is currently in doubt. And with it, that of NASA's entire Mars exploration program. Following a damning report last September, this flagship project, one decades in the making, has been put on hold. Amid talk of spiraling costs and never-extending schedule, it's starting to look like Mars sample return may soon get cancelled altogether. And that poses a vital question. How did this happen? How did a mission that was meant to demonstrate American space prowess turn into a logistical and budgetary nightmare? The answers are as complex as they are deeply troubling. Now, in the history of NASA, there are few missions that have been gestating for so long or have become so complex as the Mars Sample Return mission, which is often abbreviated to MSR. For years now, the goal of bringing rock samples back from the red planet to study here on Earth has been at the forefront of planetary scientists' minds. Serious research began back in the 1990s. Back in 2012, the Perseverance rover, which is right now roaming Jezero Crater, was selected for development mainly to help fulfill this task. A task that is supposed to include upcoming launches in 2027 and 2028 and culminate with those samples arriving on Earth in 2033. In terms of time taken, not even the Apollo moon landings can compare to that. In the modern era, perhaps only the James Webb Space Telescope has similarly gone so wildly over budget and schedule. But while the JWST blasted off in 2021 to near universal acclaim, the same thing may not happen with Mars sample return. In fact, it's starting to look like the mission may wind up getting scrapped altogether. For a mission so long in the making, this is a shocking thing to hear. Kind of like if Lyndon B. Johnson had suddenly announced to a press conference in 1968, going to the moon, wasted that time, buddy. Nothing up there but a bunch of rocks. We're stopping it. Yet, crazy as it sounds, cancellation may be the best way forward. For all the billions of dollars already poured into it, there are signs that MSR is becoming nothing but a scientific fire pit for money. At least, that's the consensus of the independent review board NASA convened last September to look into cost overruns. While their report did highlight the incredible scientific advances the mission could make, it also highlighted the ways the budget and schedule were running out of control. Instead of the $5.3 billion price tag Congress wanted, the board concluded that the overall cost would be between $8 and $11 billion. Rather than an initial launch in 2027, it predicted that the earliest MSR could fly would be 2030, and even then, only if NASA pumped in an additional $1 billion annually for at least 3 years. Now, such expenditure might be worth it. One of the main goals of Mars sample return is to bring back evidence of ancient life separately evolving on the red planet. If we could guarantee that this goal would be fulfilled, then it's hard to imagine many objecting to the sky-high budget. After all, discovering a separate genesis for life in our solar system would transform the way we think about the universe, opening up in an instant the possibility that complex, perhaps even intelligent creatures have evolved elsewhere. Sadly, MSR comes with no such guarantee. Speaking to Scientific American planetary scientist Fran Bagenal pointed out that the rocks the mission is targeting come from a long-dead lake that may have held life 3.7 billion years ago. As the magazine explains, scientists still vigorously debate any hints of life in rocks of similar vintage right here on our own, far better studied Earth. So what will we learn by spending many billions on returning such samples from Mars? Now, obviously, not everybody agrees with this. We'll explore the pros and cons of pushing ahead with the mission in more depth later in the video. For now, though, the important thing to note is that Congress seems to be paying heed to all these worries. At the time of writing, the Senate Appropriations Committee is offering a mere $300 million funding for MSR this year, far below the nearly $1 billion that NASA asked for. On top of that, they've threatened to cancel the project altogether if costs are not brought under control. At NASA, the impact of these threats is already being felt. While the agency awaits for a report in March this year to see if there's still a way forward, work has halted on many aspects of the project. 2024 opens with the Jet Propulsion Laboratory laying off 100 contractors assigned to the mission. The hope, of course, is that this is a temporary blip, a necessary scare to shock NASA into finding a way to do the project in a cheaper and more streamlined way. The problem? Well, no such way may exist. As we're about to see, Mars sample return is, by necessity, one of the most absurdly complex missions that the agency has ever undertaken. Now, Remember when the James Webb Space Telescope was first launched and news sites were filled with talk of its 344 potential points of failure? Well, Mars Sample Return laughs in the face of such puny numbers. While JWST may have been complex, it was still just a single machine. MSR, by contrast, is supposed to rely on an army of spacecraft, drones, and robots. At its most simple, the mission involves the Perseverance rover dropping sealed tubes of rock across the Martian surface, something it's doing right now. When the time comes, a Mars lander set to launch in 2028 will deploy to the same region and release a separate rover built by the European Space Agency to retrieve those samples. At least, that was the initial plan, but NASA later scrapped the European rover, suggesting Perseverance do the job instead. But then people freaked out that Perseverance might suffer issues without a backup, so the plan changed, deploying 2 flying drones to the Martian surface to help with collection. Once collected, the samples will be transported to the lander and loaded onto a small rocket using a robotic arm. That small rocket will then be mechanically hurled into the air, at which point its thruster will ignite and NASA complete the first rocket launch ever carried out on another planet. But the fun doesn't stop there, because there's no way a rocket like that would be able to fly all the way from Mars to Earth. Instead, it's meant to go into orbit around Mars, where another European craft, this one launched in 2027, should be waiting for it. With incredible precision, the two will rendezvous in outer space. That done, the European craft should then turn around and blast back to Earth, carrying the rock samples in a special shielded capsule. In 2023, that capsule is meant to be dropped into our world's atmosphere, tumbling down at high speeds before finally coming to a rest in the Utah desert. Only the next stage won't be so simple as scientists just strolling over, opening it up and going, "Yay, space rocks!" No. Instead, the capsule will have to be transported to an as-yet unbuilt biocontainment level 4 facility to stop Earth microbes contaminating the samples or Martian microbes from contaminating Earth. That's a facility with the same level of protection as labs studying anthrax and smallpox, which would have to be constructed from scratch. Finally, once inside this sealed lab, the first tube will be opened and the first sample taken. And so, the epic journey of one lump of rock from the plains of Mars to the laboratories of Earth will finally end. Now, if that sounds insanely complex, you should know that this is still just the simplified version. A condensed overview just to give you some idea of what the plan involves. The actual mission would require so much collaboration with various partners and introduce so many potential points of failure that it would easily be the biggest, most complex thing that NASA's ever done. And that's one major thing driving the current backlash. With such a complicated mission architecture, it's clear that NASA must have known the original budget and schedule were hopelessly optimistic. Scientific American has even hinted that they may have lowballed estimates in the hope that by the time the true figures come to light, the government would have been in too deep to pull the plug. After all, that's arguably what happened with JWST. Initially slated for a launch date of 2007 and a budget of $1 billion, the telescope ultimately wound up launching in 2021 at a cost 10 times greater. The important difference is that the whole scientific community was on board with the discoveries the telescope could unleash and believed in its value. With Mars Sample Return, that ain't the case, as we're out to see. Planetary scientists are divided between those who think it's a once-in-a-lifetime opportunity and those who believe it is a financial black hole. Now, when we talk about members of the planetary science community being against Mars Sample Return, we should be clear they're not opposing it because they think it won't do valuable science. Almost everyone agrees that being able to study Martian rocks here on Earth would be, to use a scientific phrase, balls awesome. No, where these experts often differ from the MSR cheerleaders is on whether that awesomeness is worth the cost, mainly because they're aware of what else NASA could be getting with the same money. Speaking to Aerospace America, ESA project scientist Jorge Vargo pointed out how, quote, "For the price of one Mars Sample Return mission, you can do at least 3 solid in situ exploration missions." By in situ, he means missions that study the samples not here on our planet, but on Mars itself. The downside to this approach, and the reason MSR exists as a mission, is the amount of science you can do on an alien world is far less than you can do here on Earth. In the same article of Aerospace America, the reporter explains how bringing along even an electron microscope to hunt for fossilized microbes would require taking an instrument several meters large into space, an impossibility given the cost. And that's just an electron microscope. To really get the best chance of detecting chemical traces of ancient life, you'd really need to place the samples in a powerful particle accelerator. Needless to say, we're not yet at the level of culture-style tech that would allow us to build a particle accelerator on Mars. However, that doesn't mean doing in-situ missions would be worthless. Robots are becoming increasingly agile and dynamic, while the AI revolution could soon allow us to analyze data in volumes we can't even imagine. It's not impossible that money redirected from MSR could, by say 2030, result in a rover so many light years ahead of Perseverance that comparing the two would be like comparing Sputnik 1 to Starlink. A rover that may not be able to detect individual fossilized microorganisms, but might be able to detect fossilized colonies. And that's just if we redirected the funds into a similar mission. If the 11 billion was decoupled from any need to hunt for ancient life forms, it could fund a joint program of multiple rovers and orbiters that might uncover Martian secrets we never even expected of existing. And this is what we'll call the positive case for abandoning Mars sample return. The one that simply thinks we could make more and maybe greater discoveries by diverting the budget elsewhere. But there's also a negative case to be made, one that's built on the fear that MSR's spiraling issues may take other missions crashing down with it. Although it has billions of dollars at its disposal, NASA's budget is not infinite. Spending has its limits, and most classes of mission can only use funds reserved for that department. Money earmarked for human spaceflight cannot, for example, typically be redirected into rovers. The problem is, MSR is now eating up a huge chunk of the planetary science budget, guzzling billions of dollars in man-hours that are needed to ensure other craft can fly. For a recent example of what that means, look no further than the Psyche probe to the asteroid of the same name. Although it blasted off in 2023, Psyche's construction was characterized by software issues and massive scheduling problems at JPL. When the launch was delayed in summer of 2022, the knock-on effect screwed over other projects. The Veritas probe to map Venus in minute detail had to be put on indefinite hold, which itself will have knock-on effects on the Da Vinci and Envision probes meant to visit the planet at the same time. The worry is that MSR might do something similar, only on a much, much grander scale. NASA today has a lot of exciting mission proposals it could be working on. There's the Orbiter for Enceladus, which would study Saturn's ocean moon for signs of life. There's a proposed sample return mission to a lovable underdog Ceres. There's even a plan to probe Uranus. The more time and money and expertise that is devoured by Mars sample return, the less likely these other missions are to happen. That's hugely counterproductive, especially when you consider the odds of finding life on Enceladus may be far higher than finding it on Mars. Now, still, we don't want to give the impression that the entire planetary science community is against MSR. It's time for us to take a peek at the other side of the argument, the side that sees the proposals to cancel this once-in-a-generation mission and wonders if the world is going mad. Now, although it might not be as universally popular as JWST, we'd be lying if we said Mars sample return didn't enjoy broad support. When the last decadal survey came out in 2022, it included as its highest priority the successful completion of the MSR mission. Given that the decadal is a once every 10 years sounding out of what the planetary science community thinks NASA should be doing, this inclusion shows that a lot of people remain extremely invested in the mission. And with good reason. As we mentioned earlier, confirmation that life evolved independently on Mars billions of years ago would be the greatest discovery in scientific history, one that would immediately blow wide open the doors of possibilities. The samples that Perseverance is now collecting in Jezero Crater are probably the best shot we have at making this discovery. Billions of years ago, the region the rover is in now was a lake, one with rivers and deltas feeding into it, a place with likely all the ingredients needed to spark microbial life. The only trouble is, finding it may not be as simple as looking for fossilized microbes. More likely, we're going to be forced to hunt for hard-to-detect chemical traces. Aerospace America suggests looking for kerogen, a complex organic compound, one they describe this way. On Earth, layers of kerogen were formed from deposits of algae, plant pollen, and plankton in mud and underwater sediment that were squeezed by geological forces. Although kerogen can be found due to non-biological processes on meteorites, examining the chemical makeup of a Martian sample in a particle accelerator would give us a much better idea as to whether it really had come from ancient algae. This is the major argument for returning the samples to Earth. It would give us our greatest chance of detecting something that would change forever how we view the universe. It would also give us more chances of confirming it. While a detection of biosignatures from an in-situ experiment would require another rover to replicate, one done on Earth could be double-checked by quickly sending the sample to scientists at a separate facility. However, it's not only where MSR's goal of finding life is concerned that the mission could prove valuable. The steep learning curve could also translate into preparation for future Mars missions. missions, specifically missions to place humans on the surface of the Red Planet. As crazy as the mission architecture for MSR is, any crewed mission to Mars that doesn't want to end in everybody's deaths will be even crazier. Food and water will have to be transported across the gulfs of space. The materials and means for constructing habitats will have to accompany them. Backups upon fail-safes will need to be included. And the whole thing will necessarily climax with a large rocket being launched from the surface of another world, a world with far stronger gravity than our moon. If we can't handle bringing back rocks from Mars, so the thinking goes, what chance do we have of returning humans? And isn't it better to test these things when only samples are at stake, rather than lives? Of course, for anyone who also thinks putting humans on Mars is a waste of money, this argument is unlikely to sway them. But there is one final major argument as to why MSR should continue. One that's likely to find a lot more purchase in the halls of power than anything that we've mentioned so far. The argument that America doesn't get to Mars first, then China will. And this isn't just standard Cold War II, the sequel paranoia. Beijing is already deep in the serious planning stages for a probe called Taiwan 3. Intended to launch in 2028, Taiwan 3 is a lander that will attempt to do what MSR is trying to do, only faster and cheaper. Rather than using a rover, the lander itself will simply drill down and take rock samples. That done, it will blast back off and return to Earth perhaps as early as 2031. Naturally, there are some downsides to the Chinese approach. By not including the rover, their scientists are stuck with samples from wherever they touch down, which may not be the most interesting place to examine. Nonetheless, Beijing winning the Mars sample race, especially if those samples have evidence of ancient microbes, would be America's biggest embarrassment since the Soviets became the first to achieve human spaceflight. As the LA Times put it, a Chinese victory would, quote, challenge the USA's technical, engineering, and scientific leadership in Mars exploration. So, those are the arguments, both for and against pressing ahead with Mars sample return. Arguments that run the gamut from cost-effectiveness to geopolitical competition. To end this video, though, we want to pivot away from those more abstract concerns to instead answer an important question: what the hell happens next? Now, at the time of writing, we're still waiting for the next key step in the MSR saga. With the project in crisis mode, NASA recently created the Mars Sample Return Independent Review Board response team and tasked it with finding solutions to the problems identified in the September 2023 review. And as we finish writing this video in late January, they have yet to make their recommendations public. Whatever the team comes back with, it'll be key to the mission's future. Following their report, NASA is planning to officially unveil their next steps, likely sometime in March this year. At that point, we'll finally know a few key things. 1, is MSR happening? 2, if it is, what mission architecture will it settle on? And 3, what is the final budget likely to be? Given all the financial issues we've outlined, this last part is likely to be key. It could be that a much streamlined version is able to go ahead at a lesser cost, or it could be that some rather creative accounting is required. One option Scientific American floated was changing MSR's definition from a planetary science mission to an all-of-NASA initiative. This would involve tweaking the design to make it fit in with other departmental budgets, such as human exploration. But if the agency could do that, it would unlock significant extra expertise and money. The plus side to this approach is that the mission would certainly go ahead. The downside is that it would become perhaps the agency's biggest, most all-consuming project since the moon landing. If the science returns wind up being less than expected, that could be a problem. Still, if MSR does go ahead in some form, then it's likely that the near future holds some intense periods of building. Of the craft itself, yes, but also of the other infrastructure that's going to have to interact with it. Remember that level 4 biosecurity lab that we mentioned we needed to keep the return samples safe? Well, work on that will need to begin almost immediately to ensure it's ready in time. European partners too will need to be informed of the finalized plans. That means some intense coordination at an international level, especially if the mission design has changed. In short, a go-ahead in March will merely be the starting gun on years of intense work. A cancellation, on the other hand, will likely spark off several years of introspection as everyone tries to figure out what went wrong and how to salvage NASA's reputation. Right now, we obviously don't know which way the decision will go, what the future will hold for this most ambitious of missions. In one potential future, we may be slightly less than a decade away from a world-changing discovery. In another, we may soon see a chastened NASA forced to undergo an internal shake-up, one that could lead to a slew of more dynamic, cheaper missions, or may just lead to stagnation and a crisis of confidence. Whichever of these futures comes to pass, though, one thing is for certain. The concept of sample returns isn't dead. In fact, it may just be the beginning. As you watch this, more and more mission proposals across more and more space agencies are turning towards the idea of returning parts of alien worlds to Earth. There's China's Tianwen-3 that will bring back parts of Mars, but there's also Japan's Martian Moon's exploration probe that will soon return a chunk of the Martian moon Phobos. Both NASA and China's National Space Administration, meanwhile, have concept plans for taking samples from dwarf planet Ceres, and just this January, NASA granted Phase 1 funding to an exploratory study on the feasibility of one day returning samples from Venus. In other words, even if Mars sample return is cancelled, it won't be the end of the line for such missions. Following the recent successes of NASA's OSIRIS-REx in returning asteroid samples, you could even argue that we're entering something of a golden age, one in which scientists may soon be able to hold in their hands fragments of other worlds from across the inner solar system. If that's the case, then we're in for an exciting future. Whether it's a future in which Mars sample return will play a part, though, is just something we're gonna have to wait and see.